Okay, guys, third and last stream of the day. Let me open up the live chat. As usually, share the streams to my Discord server. I made, I think, over 50 videos over the last 2 weeks. This is crazy. My channel is just exploding. Nice. Paper reading today. Let me just share the actual paper. We'll be reading this one. Plus exploring Opus repository. Okay, that's pretty much it. Let's go. Let's start with this paper. On machine translation of user reviews. I was recommended to skim this paper, so we're gonna quickly skim it to understand a bit better about Serbian corpuses, corpora. Okay. This work investigates neural machine translation systems for translating English user reviews into Croatian and Serbian, two similar morphologically complex languages. Two types of reviews are used for testing the systems: IMDb movie reviews and Amazon product reviews. Two types of training data are explored: large out-of-domain bilingual parallel corpora, as well as small synthetic in-domain parallel corpus obtained by machine translation of monolingual English Amazon reviews into the target language. Both automatic scores and human evaluation show that using the synthetic in-domain corpus together with a selected subset of out-of-domain data is the best option. Separated results on IMDb and Amazon reviews indicate that MT systems perform differently on different review types. So separate results indicate that MT systems perform differently on different review types, so that user reviews generally should not be considered as a homogeneous genre. Nevertheless, more detailed research on larger amount of different reviews covering different domains topics is needed to fully understand these differences. Okay, so again, this is very, very narrow in scope compared to all of the possible domains and how we usually evaluate bigger systems, bigger LLMs or bigger MT machine translation systems. Let's quickly skim the rest of the paper. That's how I usually read papers most of the time. Sometimes I just go sequentially. So training sets, let's see here, training, sentences, running words, English, Croatian, Serbian, Amazon reviews, general corpus, selected subtitles. So 55 million in the general corpus. Running words, 564 million of something. Let's see what this exactly means. Vocabulary, 1.2 million, 2.8 million. Okay. And then development and test sets, IMDb and Amazon plus IMDb across 3 different languages, small number of sentences, and then percentage of different reviews. Okay. Then finally, the comparison of the systems trained evaluated on different metrics. So we have LU, CHRF, and CTER. Let's see. So I guess this is where they pre-train on, and then the results. And apparently the best results come from reviews plus 18M, which is probably a combination of this general corpus plus this synthetic domain-specific in-domain data. Is where they get the best numbers, and they're much better, quote unquote, much better than Google and Amazon, because this is very narrow benchmark. That's why I say quote unquote. English, Serbian, similar conclusions here, I would say. And then here, let's see translation examples for the 2 best systems, general and reviews plus 18M. Arrows together with the corresponding English parts are marked in bold. For the first 4 sentences, reviews plus 18M is better. For 5 and 6, okay, let's start. So source, reference, general, and review. So these are the translations, and these are the actual the source. So let's read this. Do not buy this unless you purposely want reddish brown hair. Ne kupujte ovo osim ako ciljano ne želite crvenkastu smeđu kosu. Ne kupujte ovo osim ako ne želite slađenu kosu rediša. This is completely failed. And then ne kupujte ovo osim ako ne želite crveno smeđu kosu. This is fairly decent translation. And then here they say boring characters, dosadni likovi, dosadni karakteri. Yeah, this is kind of too literal of a translation. Wonderful skincare, odlična nega kože, predivna briga za kožu. Yeah, this is a bit weird. Maybe you could kind of understand it. This was a pretty dull movie, actually. Ovo je zapravo bio poprilično dosadan film. Ovo je bio poprilično dosadan film, zapravo. This is just less in the this is too literal of a translation in the sense of word order, but otherwise it's actually correct translation. This is zapravo is a correct translation for actually. And then let's see, so those are the first 4, and then they mention for 5 and 6, the 2 systems exhibit errors in different parts of the sentence. I had high hopes for this product after reading all the wonderful reviews. Imao sam velike nade za ovaj proizvod nakon čitanja svih prekrasnih recenzija. Ooh, my god, I would maybe, given how bad my Serbian is, I would think this is the correct translation as well. Polagao sam velike nade ovaj proizvod nakon čitanja svih divnih kritika. Well, this is actually not a bad translation either. Like, I wouldn't consider these to be... It's not perfectly... This is more of a fluency error than anything else, really. Then let's go... for 7, 8, and 9, general is better. For 7, 8, and 9, general is better. Okay. Let's maybe read them. Just I'm very curious to see the actual examples. A great story. Okay, this is bad. Velika priča is something no Serb would ever say. I don't like this kind of films. I feel like somebody's trying to pull my leg. Ne volim ovakve filmove, osjećam se kao da me neko pokušava prevariti. Which is no. This is again too literal of a translation. The translation system does not understand the actual context of what this is trying to say, the metaphorical meaning. My sense is that it depends to a large degree on the dog. Again, it's mostly word by word translation errors when it's literally translating what it means. I only recently discovered vanilla bean paste. Oh, this is something amazing. We had this, me and my girlfriend had this in Japan. This bean paste is the best thing ever. I think they're all of their desserts like mochi are made with this bean paste. Nedavno sam otkrio pastu od X vanille. This is weird. Why would it ever translate X and then this? Pastu od vanille I pasulje. I actually thought, no, then this is... I thought this is like the bean paste that you have in mochi. It's a bean paste, not vanilla. Okay, whatever. I make... Horrifying animal cruelty. Zastrašujuća životinjska okrutnost. Užasna životinjska cruelty. This is as if somebody who lived too long in the outside of Serbia and spoke only English, and their kids also speak English. This is how they would translate this sentence, including me, maybe. Poor quality cell phone charger. Punjač sa lošim kvalitetnim telefonima. This is like very, very funny translations. Siromašni punjač sa mobitel. The translation of this back into English would be poor charger, in the sense it's like it's not rich, it doesn't have enough money. Poor charger for mobile phone. That's how you would translate this back to English. Okay, funny failure cases. Comparison of automatic scores and human evaluation for two different types of reviews. Amazon products and IMDb movies. The scores are evaluated on the join, blah, 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 whatever. And then we see the general performs the best on here. Well, they're pretty much on par. On pair, how do you say it? On par. Different error types. And then finally, that's it. This work investigates machine translation of two types of user reviews, IMDb movie reviews and Amazon product reviews for English into Serbian and Croatian. Since one of the main challenges of MT of user reviews is lack of parallel in-domain training data, we explore the possibility to make use of large out-of-domain bilingual parallel corpora, as well as monolingual in-domain English corpora. We trained a general teacher system on all out-of-domain data, and then use this system to create a small synthetic in-domain parallel corpus by translating English Amazon reviews into the target languages. Okay. Both automatic scores and human evaluation show that using this synthetic in-domain corpus together with a selected subset of out-of-domain data is the best option. The results on separated IMDb and Amazon reviews indicate that MT systems perform differently on different review types, so that user reviews generally should not be considered as a homogeneous genre. However, evaluating and training on large amount of reviews covering different domains is needed to identify the nature of differences. Okay. I guess I mostly care about, I doubt I'll see anything interesting other than just understand the data. Maybe just see a bit more about how people from local region are doing research. Machine translation has evolved very rapidly. Every year, evaluation campaigns, which include both human, are carried out with the goal of advancing. The most known is the WMT share task, which focuses on news articles, and since 2016 on medical or biomedical texts, and both can be considered as instances of formal written text. Okay. The IWSLT evaluation campaign, on the other hand, focuses on the translation of TED Talks and some European projects. Investigated the translation of online lectures, and some European projects like TramMOOC and Trans Lectures investigated the translation of online lectures. In both cases, the text can be considered to be formal speech, with the challenges of dealing with characteristics of spoken language and speech recognition output. Okay. So are those separate ones? I guess IWSLT, which is a fairly common dataset, I've seen that name mentioned all around the literature, MT literature. I guess that's a separate one. On the other hand, focus on the translation of TED Talks, and some European projects investigate. Okay, so that's a separate set of evals than IWSLT. Okay. Recent interest in the translation of user-generated content in the form of informal written text has been increasing. For example, JSOLT workshop focused on translation of very noisy text content originating from sources like WhatsApp, Twitter, and Reddit. In this work, we focus on different types of written user-generated content, namely user reviews. While the style is not as colloquial and noisy as that of Twitter or of other similar sources, it certainly is much less formal than news texts or other sources that have been investigated traditionally in the MT community. There are also important applications for focusing on this kind of data, both for commercial and from user perspective. More and more companies are expanding into multinational markets, and user reviews of products have become an important asset for online transactions and a feature that many customers expect to find. And in the era of always available internet connectivity, many individuals rely on experiences of other people, not only for guiding purchasing decisions, but also for entertainment options like choosing movies, books, restaurants, etc. Okay, so just giving us some motivation on why this matters. Product reviews and movie reviews. Translating user reviews can increase and improve its reach and utility. The main issue for human translation is the fact that there is way too much content to be translated. Therefore, MT is very helpful for this kind of content. However, the genre includes several important challenges such as informal language, spelling errors, a large number of domains, topics, and lack of in-domain parallel bilingual data. In this work, we compare two approaches for building MT systems for translating user reviews: training on large parallel out-of-domain data and training on small synthetic in-domain data. I mean, I think we kind of all agree that at this point, this one, if you have enough of large, even out of domain, if it's just large, very large, you don't care about going like doing in-domain stuff. I kind of forgot, like, I think it's been like 2-3 years since I've seen, and this is exactly 2021, when I was still seeing papers like this. Like, everything changed with LLMs. We also compare MT performance on two types of user reviews. We investigate Croatian and Serbian as target languages as a case involving mid-sized, less resourced, morphologically rich European languages. For these languages, a reasonable amount of out-of-domain parallel data is publicly available to train an MT system, however, still much lower than for major European languages such as German, French, and Spanish. All of our experiments were carried out on publicly available datasets. We used Opus for out-of-domain training and a selected set of Amazon reviews for in-domain. For development, we used the publicly available texts consisting of a selected set of English. So for development, we used the publicly available texts consisting of a selected set of English IMDb reviews and their Croatian and Serbian human translations. Okay. Let's see this. Okay, very small data sets. So that was used for development. Consisting of a selected set of English IMDb reviews. For testing, we used another selected set of IMDb reviews as well as a selected set of Amazon reviews. Neither of the test reviews has been investigated yet, and they will also be made publicly available. Related work, let me just skim this quickly. Okay. Nothing super informative there. Okay, we can skip the whole related work section. Building energy systems, all are based on transformers, using this AWS implementation, SOC-I. They are balanced, both the Croatian and Serbian. 32K characters, tokens. Both for the two systems operate on sub-word units generated by byte per BPE with 32k BP tokens both for the source and for the target language text. So does that mean like English, Serbian, and Croatian? We do not use shared vocabularies between the source and the target because they're distinct. On the other hand, we built a joint vocab for the two target languages because they're very similar. All the systems have transformer, again 6 layers, blah blah blah. Okay, teacher-student mode. As a first step, we built a system trained on all publicly available plural data, 55 million sentences. This data, however, does not contain any user reviews. Okay. Okay, so they just took the monolingual data, they trained an empty system on the out-of-domain data, and then they used it to translate, to basically translate from, to do forward translation into Serbian and Croatian, and then they trained on that data. In our setup, knowledge distillation is used for domain adaptation. The teacher model is a system trained on a large amount of out-of-domain parallel data. This system is used to create a small synthetic in-domain corpus, which is then used to train the student model. Advanced student model, the best option for using synthetic training corpora for NMT is not to use them alone, but to enrich natural parallel corpora. However, we do not have any natural corpora, yet some parts of the large out-of-domain corpora might be more useful for translating reviews than others, especially subtitles, which are usually informal spoken language. To explore this potential, we ranked out-of-domain sentences according to their similarity to user reviews and extracted the most similar ones to combine them with the synthetic parallel corpus and train an advanced student model. The details about all datasets and data selection are presented in the next section. Okay, so advanced. So we ranked out-of-domain according to their similarity to user reviews and extracted the most similar ones to combine them with the synthetic parallel corpus. Well, don't they already pre-train on that whole out-of-domain and then additionally on this in-domain? In which case, why does it care? What is advanced about this one? Not completely clear. Okay, datasets, user reviews, IMDb movie reviews consist of about 10 sentences. Okay. They were used for development and testing, but not for training. Amazon product reviews, 5 sentences and 93 words on average. Each review is labeled with a rating from 1 to 5, divided into 24 categories. And they use from all these different domains. For our systems, were used for both training, blah, blah, blah. However, not for development. In order to obtain a balanced multi-target training corpus, half of the selected reviews from each of the topics were translated into Serbian and another half into Croatian. Out of domain, we use the public available opus. As out of domain, the vast majority of these resources for the desired language pairs consist of open subtitles, and there are also Set Times, Bible, TLD, EU Bookshop, QED, and Tatuiba. I think this is literally the same data sets as in the previous work. Okay. As mentioned in section 2, we extracted a set of sentences from the out-of-domain subtitles according to their similarity to the reviews. They were ranked using FTA. Okay, we read this in the previous paper as well. We can skip this. Okay, that we then use the seed, which are the reviews, to extract similar sentence pairs from English Croatian and English Serbian subtitles. And for each target language, we selected the top 9 million sentence pairs, thus 18 balanced sentence pairs in total. Okay, and then table 1. So it's kind of cheating, right? You know you want to train on that domain, and then you find similar sentences from the out of the main corpus, and you just train on them. Table 1 shows number of sentences, running words, and distinct words in training, development, and test set, as well as contributions of each review types. Okay, let's go to table 1. And then experimental setup. We're almost done. This is a very short paper and not that much information. So sentences in the general corpus 55 million, in the Amazon reviews 3.9, almost 4, and then selected subtitles 18 million. Running words. Okay, so I guess around 10 words on average to get from here to here. And then vocabulary. What do they mean by this? What do they mean by 1,000,000.2 vocabulary? There is not that many words in, I think. Okay. I think like maybe 50,000 words. If you know, like even natives don't know that many words, like even 50,000. They're alone 1.2 million. So this is, what is vocabulary? Okay, and then development, and okay, let's go. In order to systematically explore influence of different sizes and nature of trained data, we build the following empty system. General, trained on all publicly available out-of-domain reviews. System trained on in-domain synthetic corpus consisting of original reviews and their translations generated by the general system. Reviews plus selected advanced student. System trained on combination of synthetic in-domain data and selected natural out-of-domain data. Okay, and then results. In order to get quick feedback about each of our systems, we first evaluated them using the following 3 metrics. To get a quick feedback about each of our systems, we first evaluated them using the following 3. The 2 best systems according to automatic scores, the teacher system general and the advanced student system reviews plus 18M, were also evaluated by human annotators. The evaluators marked all words considered as adequacy errors, as described in this paper, on a subset of about 200 sentences per system. The results are presented in table 2. And the tendencies are the same for both target languages. As expected, the small synthetic in-domain corpus alone reviews cannot achieve the same performance as the general out-of-domain corpus. However, the difference in scores is not so large as could be expected, considering the difference in the sizes, as well as the fact that the target out of the in-domain corpus is machine translated. Adding 6 million of selected parallel sentences slightly improves the performance, while additional 6 million yield and even slightly improve the performance of the general teacher system. Adding 80 million only slightly improves over the reviews plus 12 and definitely outperforms the general teacher system. We also present the scores for 2 online MT systems, Amazon and Google. Outperform both of them, although their automatic scores are notably lower than the 2 best systems. They were also evaluated by human annotators in order to gather more annotations for comparing 2 different types of reviews, which will be described in the next section. So they present the scores for Google and Amazon, and it can be seeing that our two systems outperform both of them, that our best two systems outperform both of them. Although their automatic scores are notably lower than the two best systems, they were also evaluated by human annotators. Before moving to that, we will present a set of translation examples for the two best systems in table 3, which we saw in the beginning of the video. The first 4 sentences present examples where the review-oriented advanced student system performs better. The word order is not optimal. Guys, I'm really looking forward to training like English to Serbian just to see how it works, because I speak both languages, so it's gonna be fun. The last time I trained Turkish and Hindi, so it was not that fun because I don't speak the languages. Okay, they're just describing the types of errors that happened in the table that we saw before. Okay, too much focus on 10 translations, but okay. Comparing Amazon and IMDb reviews. Separated scores for joint target languages are presented in table 4. Okay, this forward translation definitely helped, because this system reviews plus 18M was better. Furthermore, for all systems, automatic scores are notably better for Amazon product reviews than for IMDb movie reviews. Notably better for Amazon product reviews than for IMDb. Indicating that IMDb is more difficult. Okay. However, the tendencies of human scores are different, except for Google. For other systems, R2 and Amazon, the evaluators found less errors in IMDb than in Amazon reviews. Okay, they did train on Amazon reviews already. After looking into errors marked by human evaluators, in order to identify the most prominent error types, we found out that there are some differences in frequencies of certain error types, present in the table 5. The largest difference can be seen for named entities, which are generally more frequent in IMDb reviews. Okay, untranslated words, English words copied into translation, as well as non-existing, which do not exist either in the source or in the target. So different types of errors. Biggest for named entity, which are especially frequent in IMDb. Okay, all these results indicate that there are differences between different types of reviews. Yeah, this is just, it's fun how small scale some of these old papers were. Still, that was a useful read. Okay. More ideas here and here. Let's go. Let's just play a bit with Opus. Let's play a bit with Opus. Let me maybe put this here under like previous runs. Whoops. I could probably just link weights and biases stable. This was the first run. It was a fun one. Where is the train loss? Why is this not? This used to be very, here it is. This is something weird because train inner is what we're looking for. These were our metrics. Let me just save this here. Weights and biases, and biases run is here. So that's it. And then let's go back to to-dos, which should be separated out here. Okay. To-do for the next run. This is more of a tip. Just move it here. Okay. So let's analyze this Opus and Makoku data sets and see what we can extract there. And if we get enough Perl bytext here, I might just kick off a run immediately with English and Serbian creation and whatnot, so I can debug that and yeah, see how that goes, learn something. Let's start here. Let's just get some familiarity with how this thing works. There might be some overlap between what we have and what is inside here, because I already see some familiar names here, like this Xosa Navy, whatever this means. I also see Tico 19. I think we have all of those. If we take a look at our data under modeling data, wait, where it is? Where is it? Let me find it. Train data sets, and then Tico. So here's Tico data set. So we have, I think it's also Tico 19 as well. I think I just renamed it. And then CC Align. This is, I guess, common crawl stuff. Paracrawl, CC Matrix. Isn't this the work that came from Facebook? I think it is. It's mine data from Common Crawl. I think this is, yeah, Facebook using laser. Let's kind of go and analyze this website just to understand what's going on. This corpus has been extracted from web crawls using the margin-based bytext mining techniques described in this paper on CC Matrix. Okay. In addition to the files shown on this web page, Opus also provides precompiled word alignments. What is that exactly? Is that like a dictionary? And phrase tables, bilingual dictionaries? Apparently not. So there's some difference between whatever the word alignment is. Bottom left triangle, download files, upper right sample files. So these ones are for download, and then these are for view. Nice. CES, sentence alignments in XCES format. Leftmost column language IDs, tokenized corpus files in XML. Tmax and plain text files, Moses, see statistics below. Lower row, language IDs, parse corpus files if they exist. Wow, this is as succinct and concise as it gets. We need to pass in our verbose flag here. CS. So if we just open this, what do we get? This is some XML, I guess. Let's just click a couple of things and see what we end up with. So here are the language codes sorted alphabetically. Let's try and find Serbian, like S, D, S, I, S, K, S, L, S, O, S, Q, S, R. This is the Serbian, I guess. So then Serbian with, where is English, for example? English is here. Let's scroll down there, scroll until we get to here. Let's open it up in the second page, or maybe just let's download it quickly to, I don't know, like maybe documents and then empty. Let's download it here. And then let's open it up. Whoops. Okay, let me just see. How do we extract this? What's the command for extraction? tar something. Extract from gz ubuntu. Okay, let's go. English Serbian. I'm extracting. Okay, this might be a bit bigger of a file, by the way. Let's see. 2 gigabytes, nice. Okay, maybe we can just cat a couple of sentences. How can we do cat only first 10 lines or something? Okay, let's go and do that. Maybe we can do something like this and then. Okay, let's go like first 10 lines. Okay, and then let's, I don't know, let's go first 100 lines, and then we can just scroll. Okay, ton of links. Can we just go? Okay, this won't be super useful. Could we just make it like interactive so I can just keep on grabbing new rows? Is there any way to just grab the rows interactively as opposed to having to specify exact number of lines before? Let's see whether this fails. Probably will fail. I tried to open up the 1.9 gigabyte file. My Explorer is dead. I knew that's gonna happen. Hopefully my whole system doesn't crash. Okay. So those are some CS, HTML, CC matrix, V1 XML. So different languages, different data there. So that's below the diagonal. And then above we just open. So I should have just, I'm kind of stupid. I should have gone with just source here Serbian here and then English on the side here. Let's find it. English and then Serbian. Your enemy has to be poverty. Vaš neprijatelj mora da bude siromaštvo. God's plan is for you to create anything, everything, whenever, whatever you want. Jer Božji plan za vas je da stvarate bilo šta, sve, što god želite. God's plan is for you to create anything, everything, whatever you want. Wait, didn't we have that already here? Bestow on us the grace of repentance, O merciful and compassionate Master. Okay, I also see a mix between Cyrillic and Latin script, because we have two different scripts. Let me just try and kill this process. Sorry, just a second. It's not responding. Force quit. Can I force quit it? My editor is dying on the other page. Let's kind of just skim through this. Results. To us, God's character. Vidite Sotona laga o Božjem karakteru. Whoever my father was, for an hour or for a month, he must have been a happy man. It's interesting, we always have these quotation marks here. Okay, this is all Bible. Atom je sve ono što smo mi. And Adam is all that we are. Look at this translation. Beautiful. There is a ton of these weird characters here. Bible tends to be good, nicely translated, which makes sense. And it's mostly Bible. Everything I've seen here so far was Bible. Okay. Whoops. Let's go back. Anything else that's exciting here? CS. So again, let's just read this. Sentence alignments in XCS format. Leftmost column, language IDs. So I guess we can also open up these. So upper row, language IDs, monolingual XML file samples. So if you open up these ones, just some file samples. And on the rightmost side, untokenized corpus files. Okay. Okay. Statistics and TMX. Moses downloads. Number of files, tokens, and sentences per language, including non-parallel ones if they exist. Number of sentence alignment units per language pair. Upper right triangle, download translation memory files, TMX. Bottom left triangle, download plain text files. Language IDs, first row. Monolingual plain text files, tokenized. Language IDs, first column. Monolingual plain text files, untokenized. Okay. Let's see for Serbian. and then English. $26 million. That's a lot. That's really a lot. Okay. I have no idea what some of these words mean. TMX files only contain unique translation units. Let's just grab one of the smaller files, like this one maybe, and just see what it does. Go there. Let's just unzip this one. Whoops. No. I accidentally, wait, force quit. Okay. Just a second, let me open up this. Open collection of parallel corpora. License. Scores while mining. And then I guess these are the parallel corpora. Yes. Okay. That's what I was looking for. So number of files, tokens, and sentences per language. So let's see for Serbian. Number of files. All of them have just a single file as far as I can tell. Number of tokens. Serbian has 665 million tokens. And then sentences. 50 million sentences. That's a lot. Let's see, for example, for Croatian. Croatian should be either, I guess, HR. Yes. A bit less than Serbian. Let's see, German. Not much more than Serbian, which is weird. So Serbian has like 664 mega, which is similar to German. No, actually much less. Sorry, like 10x less. And then let's see, English. Yeah, English is like crazy, as expected. Upper right. Let's see what this TMX is. Let me understand what TMX is. Let's open up something that's small, like this one. TMX. Let's save it here. And let's do the same thing. Let me go back. TMX. Let me just delete this. And let me unzip gzip and then file name gzip-t and then file name ilo blah blah blah. Okay, this is TMX apparently, which they say is what? Translation memory files. So this just looks like the regular parallel corpus, just in a different format as part of the same file. So why is it called translation memory? Just a fancy way of calling this format. Okay. Do we have anything else here? Nope, that was it. So that's that data. And bottom, download plain text files. Moses and Giza++. And then we have monolingual plain text files. Okay, so that's how this, just trying to get some familiarity with the interface, because I think it's going to be very similar to for the other data sets. So those were the latest news. We just opened up Opus on GitHub. 6 stars. Okay. Opus MT. Opus Translator. There's just a ton of resources. Links to other resources. Acknowledgements. HPC resources. Okay. So they just have a ton of different repositories. All of them look like they came from the 90s. Interactive map of Opus MT language coverage. Live demo. Leaderboards. Blue. So they show for any of the particular benchmarks, they compare their work 52.2 against the best competitor, which is here NLLB, and they're better than NLLB by 4.2 points here. Why would they pick only a particular language? This is just English French, I guess. For different benchmarks, they're apparently better than NLLB on most of these. Blue Opus MT, gray external. Okay. Let's see, can we pick a language? Yes. Let's pick, for example, English and Serbian. Which one of these should I pick now? Okay, here. They don't even have anything there. Let's see Cyrillic. Apparently they are a bit better. English HBS, which is Croatian, Bosnian, and Serbian. They're a bit better than the baseline. Well, by 5 points, so not a bit more. Let's see English Latin. Okay, again, no scores. Cool. Let's see what else they've got. Empty web service setup. Is this like open source or what? Server license, MIT license, nice. Okay. Apparently this just enables you to host your own empty models. Okay, they just train. This is not like trying to be state of the art at anything. This is just showcasing stuff. Okay. They host all the models here apparently. They store public models here for different languages. Hosting the server, Docker, manual setup, blah, blah, blah. Trained using their system here. You train models, we've seen this. Demo translation interface. Broken link. Broken link. Okay. Ingesting data into Opus. Online dictionary based on word alignments. What's this one? What does this do? German, Dutch, Italian, Hellenica, this is Greek, I guess French, Spanish, miel, that's actually correct, honey, Probability of this one is the highest. One-ish. This is also correct. World alignment database. Online search. I guess that's the website. A toolbox for filtering, compiling parallel corpora. API for searching open resources, for processing data. Years ago. Okay, so they just have a ton of resources, but everything seems very, very low quality. Website, GitHub. Okay. Going back here. Publications. Look at this. Total page views. What's this? Links to other resources, Europe Parallel Corpus, WMT data, some projects using Opus, tools and information, search and browse, Opus multilingual search interface. Let's see what that one is. Open subtitle search interface. Let's see what that one is. Subcorpora. CC matrix. Is that going to be the one we've seen? Yes, looks like it is. Montenegrin subs, Montenegrin movies subtitles. My girlfriend is from Montenegro. Belgish creation. Okay, and then books maybe. Let's just open up a couple of those to see how stuff works and looks like. Paracrawl maybe. QED. Tatoeba. TED Talks. Ubuntu. I did open it up. You're gonna see it in a second. It's gonna be spectacular. Search and download resources. So if we just picked up, like, let's find Serbian. Serbian. And then Serbian and German or English. And then let's say all. Let's see what we get here. So we get 2 corpora, in total 55 of something of documents, 4.3 thousand sentences, that many tokens. Okay. And then apparently, why is there so little text here? Okay, nothing. all. Okay, let's see. Let's go. Maybe we have to go from English to. Maybe it's not symmetric. Let's go from English to Serbian. OPRS PQRS SRP. Here it is. All. Why is that so little data? Or am I doing something incorrectly here? Show all versions. Why do we have only so little if we saw millions of sentences from Opus in the previous papers we read? No manual corrections have been carried out. Worth knowing that. What's this? Let's analyze these. Let me just, I need to stretch my legs for a couple of minutes and I'm gonna be back. And then we're gonna continue analyzing the opus and everything they've got. 3-minute break. Be right back. Break with 1E. See you soon, guys. Okay, I'm back, guys. Let's go back to this. Delete this. Okay, let's see the Montenegrin subs. Let's kind of skim through a couple of links I've opened up here. And also let's see what these links here are. Does this use isomap? I'm not sure what you mean by isomap. Word alignment, Wiki. Okay, let's see one by one what these are. Just trying to get some familiarity with how this works. Like geodesic distance, computing for reducing dimensionality. Yeah, but like in the context of machine translation, what does it? What exactly did you mean? Let's see this one. 2 languages. Total number of files 220. Total number of tokens 1 million. Cite the following article. Jörg Tiedman, that's the Finnish guy behind Opus. Download. Before you can download data files for all language pairs in different formats. Below you can download. You can click on the various link. Opus additionally provides precompiled word alignments and phrase tables. Bottom left, download files. Upper right, look at this table. Huge. English Montenegrin. Let's open up this one. Let's see how the translations look like. Blood, half naked, wandering the streets at 7 a.m. Krvava, polugola, luta ulicom u 7 ujutro. Just your type. Tvoj tip. You get the name. She's not responsive. All we found on her was this. So far you wouldn't be able to distinguish this from Serbian. It's like this is fun. The rest is a mess. Ostalo se ne vidi. Or her John. Ili clean. So this is holy shit. Dođe vola. Damn right, holy shit. Imaš pravo. Congratulations, čestitam. The punctuation is completely messed up. Why is there space between these two? How can we know this is Montenegrin? Statistics and TMX Moses downloads. So here's the number of English 110 files. Monolingual data. So that's the Montenegrin subs. Creation English parallel web corpus. Automatically extracted from the HRWAC corpus by Nikola Ljubešić. Okay, we know this guy. He was actually involved. He replied to some of the comments on my LinkedIn post. These candidates were manually checked by Dasha Berovic and Daniela Merkler under the supervision of Marko Tadic. The collection is available here under the share alike license. 2 languages, total number of files. Below you can download data. Let's see. There's probably no person in the world. So I see the J, so I can now tell this is, by the way, this is like one of the rare differences between all these languages in the region where I live. You just have this additional J letter, and then you call it a different language with some different words, of course, but like mostly the same. All of these Serbian, Bosnian, Croatian, Montenegrin, it used to be called Serbo-Croatian a couple of decades ago, and now we have 4 languages. So that's why it's so hard for translation systems to like translate with all of these small details. Okay. I see the J. Alex's way of saying it's Yakari. It's like literally one J letter. My girlfriend is laughing because she's from Montenegro. I'm just like trolling. Like it's okay. Okay, so what's the difference? So this is HR English WAC from this bigger corpus. Okay. And then there are books. Is this the same type of books that's inside of pile? Texts are rather dated due to copyright issues. In Opus, the alignment is formally bilingual, but the multilingual alignment can be recovered. Note also that the alignment units from the original source may include multi-sentence paragraphs which are split and aligned in Opus. Is it? No, this is just books. It's not books. Books 3 is the name of the dataset. Paracroll version 9. Collected in Paracroll, which is of course dead. Dead links. That's internet. Okay. Mostly English with other languages. QED. Okay, so I guess it's all the same for all of these. Let's maybe quickly just analyze the details behind these ones. Did they say anything about this dataset? 397 languages. Number of tokens 80 million. Tatueba. What's this? Voluntary contributions of thousands of members. Provides a special tool for you to see examples of how words are used in the context of a sentence. The name Tatueba, for example, in Japanese. So it literally means, for example. Okay, I've seen that dataset name mentioned. Okay, TED. Real corpus of TED Talks subtitles. Okay, what's this? And this. Corpus query, as the name suggests. Okay, and then what you can do, you can query using some weird syntax. I guess you can just use view as well. You don't really need this. CQP demo, search the open subtitle corpus with CQP query. Okay, again, just some tool for querying the data that they offer. I think I've even seen a GitHub project where they've implemented that particular web app. Okay, Opus is a growing collection of translated text from the web. We try to convert free online data, add linguistic annotation. Main purpose is for data-driven NLP, especially statistical machine translation. Oh my god, they haven't updated this sentence for 10 years, I guess. Therefore, we provide various downloads of parallel datasets that can be used immediately for trainings. Note, however, that we provide the data as is without any warranties and guarantees. All pre-processing and alignment is done automatically and no manual corrections have been performed. Be aware of errors and noise. The quality may vary substantially. Please acknowledge your work, blah, blah, blah. Tools. How to download the datasets. Can be downloaded in various formats. Easiest way to find resources to use the form at the front page of Opus. So that's the one where you pick stuff and then you download. Select the languages you're interested in and look at the datasets provided in the table that shows the results of your query. Here's a recent snapshot that shows resources for English and French with more than 1 million parallel sentences, source and target language together. So here they picked English and French and selected the size, and then they found link to the corpus website, number of documents, sentences, tokens, data in XML, tokenized, untokenized, bilingual, aligned, monolingual. Most table cells contain links to the appropriate resources. Click on them to download the data. Contains the archives with a native XML format that Opus uses to store all data. XCES, sentence alignments, a standoff annotation, language IDs. TMX, parallel data in the translation memory exchange format. Moses, parallel data in plain text format without empty alignments in the format used by Moses. Mono, raw, untokenized. UD, parse data. word alignment and phrase translation tables. Zoom if you can see. A sorted frequency list of source and target language texts. Furthermore, there are sample files and query interfaces that you may look at for some corpora. Language IDs in the leftmost column are linked to file archives with corpus files using a standalone XML format. The links on CES point to the sentence alignments for corresponding languages. Oh, they have an API. Wow, wait. The upper right triangle. Web API. Still experimental. Yeah. Seven years ago. Okay, so I guess to download the data, we just go here. Can we search? What's this? 784. What data is 784? And then we cannot select anything. Okay, this is just broken. Likely broken. Chinese, Yiddish. Hopefully at least it's sorted alphabetically. I mean, it looks like it is. Okay. Let's see, for Serbian, it seems like there is too little data compared to what I've seen before. Serbian is only, okay, so there is the Serbian Montenegro, there is the Serbian here, there is the Serbian this one, Albanian. So there are three types of Serbian. That's why, and there is a Serbo-Croatian. Oh my god. A mess. Okay, so 4 types of quote-unquote Serbian. Let's see. Serbo-Croatian. And let's say English. Okay. So here's the data. Let me take a snapshot here. Just make sure that if I choose different directions, we don't have different data. So if we go like this, we go like this, let's just take a snapshot. Okay, and then what if I pick English here? Will we get the same? So DGT, Wikimetrics, Excel, and QED, that Wikimedia, blah blah blah. 8 in total, as far as I can tell. 1, 2, 3, 4, 5, 6, 7. Okay, let's pick English here. A B C D E as in English, and then here go back to OPRS Serbo-Croatian. Is it gonna be the same? 1, 2, 3, 4, 1, 2, 3, 4. Yes, okay, it's symmetric. I know this seems like a silly check, but errors like this happen. Okay, so we don't care about we can just pick the data. Let's start maybe downloading this. So how much data do we have? We have this many documents, this many 2.5 million sentences, 1.1 giga tokens, billion, I guess. Okay, so let's see. Let's do it like this. Let me quickly open up one of the previous papers. We just take this, put it here. So they mentioned opus, and let's just see how many. So they had 24 million. So we're expecting to see roughly 24 million. But they use both English and German, right? For English and both target languages, we also use set times new, Bible, blah blah blah, EU bookshop. Okay, makes sense. ED. Those are all basically listed on Opus website. In addition, we use global voices for Serbian. Let's see what global voices are. I'm gonna add that here as well to just double check that. Okay. So apparently this should give us 24 million. But they use Serbian and Croatian, and they use German and English, so that's why they get so much. Okay, just looking at some numbers, what we should expect. So that was, the name of that paper was Neural Machine Translation for Translating into Croatian and Serbian. And then in the other one, we had one more. Let me see whether the numbers are the same, roughly. So in this one, we have number of sentences, $55 million. $55 million. What's the data again here? Let's go and find Opus. Okay. So again, this seems to have even more data. Looks like they have 55 million. And here they only use English. They don't use German in this paper, because they already showed previously that German is very low quality. So 55 million here. So we need to, so between 25 and 55 million is some expectations apparently. So here we had 24. Okay, so this is Turbo Croatian. Let's see if there is, do they have Croatian? Just Croatian. Which should be, what's the ISO code for Croatian? Is it always HR? Which is a funny name, by the way. HR. Croatian, yeah, always HR or HRV, if almost sounds like HIV. Let's see. HR, find HR, Croatian. Wow. Wow. 112 million here. There is a ton of data for Croatian. Apparently this is in sentences. A ton of data. From open subtitles, well, most sentences come from here. And CC matrix, so mind and noisy, and then NLLB, nice. Wait, how come? Because I can't find any. Aha, probably from the mind data of NLLB. Yeah, mind. Okay. Okay, let's now go. So we've seen Serbo-Croatian, we've seen Croatian. Let's see just Serbian, what they say there. Serbo-Croatian. There were 3 more Serbian languages. Serbian, Montenegro. So there was a Serbian. Let's see this one. Okay, this one is also very big. 106 million. Again, open subtitles mostly. CC matrix, NLLB, CC aligned. Most of those are just mined. We're gonna have NLLB either way. Okay. And then let's now go to Serbo-Montenegrin. We had SRP. That was super low resource, and then there was also this one, Serbo-Montenegrin. Okay, this one is super small, like 1.4. Okay, cool. So let's download all of this. Basically, I'm gonna put a note here. Download data from Opus for Serbian. And also Croatian. Oops. Download data from Opus for Croatian. Just typing some notes. Sorry guys, I'm typing on a different screen. Let's see where we have data for Bosnian. Is there any chance that Bosnian folks were gonna have some sources? So Bosnian BS BS is the Bosnian BS is the letter code, or bus BS bus. Best acronyms ever, guys. Okay, where were I? So we're looking for Bosnians, I guess. Looking for BS or BOS. BA, BAM, BE, BR, BS. Here is the, and then there's the BSN, whatever that one is. Bosnian. Okay, there is also some data here. I wonder what's the overlap. What's the overlap here? There is a lot of sentences, 50, almost 100 million. I doubt these are probably just heavily mixed with Serbian and Croatian. Is there BOS as well? So BS, BOS, BO, nope. And then what else? Do we have Macedonian? Oops. Macedonian, MK or MKD. I don't have any funny remark here. MK, Mike, MK, Macedonian. How big is this one? 33 million as well. Okay, mostly just mine from NLLB and C Matrix. Everything else is tragic. Both of these projects are basically from Facebook. CC Matrix and no language left behind. MK, so that's the only one there. Okay. And Montenegrin, is it even a language officially here? Well, apparently not. Wikipedia doesn't recognize Montenegrin as a language. What a political stance. Tragic. Okay. That's it. We're gonna download a ton of that data and do some analysis. So let me just put a note for Serbian, Croatian, Bosnian. Well, there was the SR_ME, which is a Montenegrin version of Serbian or whatnot. Bosnian, Croatian, Serbian, and then is there anything else there? So those are like the most similar languages. Then later we can expand to Slavic, and then ultimately we're gonna train on the whole set of 202 languages. Let me just think here. That's pretty much it. Macedonian and Bulgarian are kinda, but not really. Macedonian is the most similar one later after these ones. These ones are the most similar ones. So we're gonna download these ones, and then data from Opus for Serbian is gonna be target. And then we can, for source, we can grab, I guess, just English. And just create a strong bilingual model. So that's Opus. Now let's go and see this global voices quickly. What is this one? What is this? Okay, this looks like just some blog. Receive great stories from around the world directly in your inbox. Your global voices. Where is the data set? Do they offer any data? Request a code. Global voices, Serbian data set, something like that. Okay, I see something on papers with code. Parallel global voices. Let's see. Here, multilingual dataset for evaluating cross-lingual summarization methods. It is extracted from social network descriptions of global voices news articles to cheaply collect evaluation data for into English and from English summarization in 15 languages. So this is mostly for Wim et al. So this is mostly for summarization, apparently. Okay. Let's see. What is this? Extract social network descriptions to cheaply collect evaluation data for into English, blah, blah, blah. For the into English summarization, we crowdsource a high quality evaluation data set. So this mostly looks to be a translation. We collect two types of summary and then translations. Is there Serbian here? No, I doubt this is the same thing they were mentioning. Let me see whether this paper mentioned the... Could it be this one? Probably this one. Parallel global voice is a set of parallel and monolingual corpora. Okay, and then we can download XML. Download. Language. Oria. Dutch. Burmese. Serbian. Let's just see. Did this guys mention global voice? Global voices. Nobody mentioned that one. Global, wait. Global voices for Serbian. Well, something popped up. Is this like... like a news? Somebody probably scraped the data and then... but I don't see... no link here. I'm gonna ping the author of this paper quickly. thing so that I don't forget. Okay, let's continue. This can remain under question mark. Let's see Makoku, and then tomorrow, once we're done with this, tomorrow in the morning, we're gonna download all of the data. We're gonna process the data, and we're gonna kick off a run by tomorrow night, hopefully. So that's kind of the idea here. Let's see Makoku. Here is that same author that we've seen a couple of times. Crawling and monolingual curation coordination. So he's mostly focused on large language models for Croatian, Serbian, and Bosnian, etc. A lot of them are from this Josef Stefan Institute. Sponsored by European Union to collect the data from June 2021. Papers. Massive collection and curation. Benchmark for discriminating between Bosnian, Croatian, Montenegrin, and Serbian. Interesting. Get to know your parallel data. Benčić. Fun. Okay, let's maybe skim through this one quickly. Those are the papers. And then there's this paper that tells a bit more about this Makoku effort. Oh, it's just 2 pages long. We can quickly skim it. Do you guys see the page? Massive collection and curation. Rolling from top level domains and then curating the data. They'll release free open source web crawling and curation software used. I think I've actually seen they have a very cool crawler for this project on GitHub. Five under-resourced languages. So this one is for Croatian, and then Macedonian, and then Montenegrin and Serbian. And for the languages of the 5 candidate states to become EU members. Oh, optimists. They make me sick. Maltese and Icelandic were chosen since they are especially under-resourced official EU languages. Existing initiatives producing similar corpora such as Paracrawl or Oscar exploit existing resources such as Common Crawl or the Internet Archive. In contrast, our strategy consists in automatically crawling top-level domains with the potential to contain substantial amounts of textual data in the targeted languages, and then applying a monolingual and parallel curation pipelines on the downloaded data. This approach aims at obtaining more and higher quality data than that available in existing compilations. One of the objectives of the project is to identify data relevant for digital service infrastructures. Our corpora will be enriched with information about the relevance of the data collected for 10 DISs. International Consortium. Strong background in the task of building corpora, as several partners have been also part of the consortiums behind projects such as Paracrawl, Gourmet, Europat, and Abu Matran. Outcomes of the project. So that's, I guess, the main difference is they are literally crawling directly the top level domains. That's interesting. Enriched with personal information identification. Translation needs. So they've released some data already. All the code developed within the project to crawl, curate, and enrich will be made available under free open source licenses on Makoku, blah blah blah. Let's see this one. That might help us understand how data was processed. So here are the data sets that were released at this point. So it was creation 7.3. Okay, this is just, I guess, are measured in millions of documents. Okay, 7.3 millions and millions of words. Parallel are also measured in millions of parallel segments. So 3.1 million segments. I'm not sure what's the definition of segment versus sentence. Okay. And then let's see what they've got here for training LMs. Nice, let me see this. Wow. Fine tuning on GPU, TPU errors. Don't even get me started. Data. What else do they have here? I've seen this one. So the crawler. And curation. Okay, nice. Nice, nice, nice. This might be useful. Okay. So this is literally explanation of how they apparently exclude the data manually. And then they have the crawler. So this thing basically crawls domains if you want to do scans yourself. And then what I'm, I guess, mostly interested in is this curation. What do they do with the data? But that's going to be more interesting once we start and if we need to collect our own data. There's a ton of steps apparently. Calling and some pre-processing. Okay. Overview of steps. Pre-vertical format. Cleaned. Tokenized. Deduplicated. Okay. Ton of stuff there. But it's interesting to know that this was basically, this is again mined data. Let me quickly skim through this paper and then let's see how can we download data here. Let's first see how we can download the data. International sources, top tier corpora. Okay. There have been two different releases of Makoku. Some languages were released in both and some just in the second one. The processing pipeline changed among versions to bring fixes, improved filtering, and richer metadata. So I guess we just select the language here. There's a version 1, release 1. So you can download and explore. Is there an overlap between these two? Aha, this is the parallel, this is the... Got it. So they have 2 million sentences here. Ukrainian, Turkish, Serbian, Montenegrin. Okay, so that's their tool that they've used for collecting the byte text. This is how it's created. Okay, let's see Serbian. Let's see Bosnian, how much? 500k sentences there. That's cool. Bulgarian, Croatian. Croatian has a ton. Parallel, 2 parallel. And they have also 2 releases. So I'm not sure whether they are deduplicated. I can ask Nicola actually. Dutch, English, Greek, Icelandic, Macedonian, Maltese, Montenegrin. This one is super small, only 218k sentences. Okay. Let me just ping Nicola for creation. creation. Let me take a snapshot of this thing. Screen capture. Okay. Just send a message. Find the person and ask him whether these are deduplicated. Are they mutually exclusive or is there any overlap there? Okay. Okay. Done. So that's going to be where we download data from. And let's wrap up tonight's stream by just skimming through this bench sheet, a benchmark for discriminating between Bosnian, Croatian, Montenegrin, and Serbian, which is the worst task in the world, trying to distinguish between these languages. Automatic discrimination between Bosnian, Croatian, Montenegrin, and Serbian is a hard task due to the mutual intelligibility of these South Slavic languages. In this paper, we introduced the benchmark for discriminating between these four languages. Consists of two datasets from different domains, a Twitter and a news dataset, selected with the aim of fostering cross-dataset evaluation of different modeling approaches. We experiment with the baseline SVM models based on character engrams, which perform nicely in dataset but do not generalize well in cross-dataset experiments. Thus, we introduce another approach exploiting only web crawl data and the weak supervision signal coming from the respective country language top-level domains. The resulting simple naive-Bayes model, based on less than 1,000-word features extracted from web data, outperforms the baseline models in the cross dataset scenario and achieves good levels of generalization. The status of separate language for Bosnian, Croatian, Montenegrin, and Serbian is frequently discussed and is in academic circles mostly understood as related to the construction of identity and diverging and converging tendencies throughout history. While each is an official language in the respective country with a separate top-level internet domain, their mutual intelligibility cannot be disputed. Regardless of the mutual intelligibility, differences do exist. In this paper, we introduce a discrimination benchmark based on two datasets, a newspaper-based one covering 3 out of 4 languages and a Twitter-based one covering all 4. The publication of this benchmark coincides with the 10th anniversary of the Vardile workshop, in which this language group has been involved from the beginning. We introduce two datasets that we now encode with maximal structure and publish in an academic data repo. Following the FAIR principles, we introduce a benchmark based on the two datasets and present baselines for the benchmark. Given the low performance of these competitive baselines on the benchmark, we introduce a new web dataset based method that shows to carry specificities of each language across the two datasets much better. Okay, a new web dataset based method. Benchmark datasets, two rather different datasets. Southeastern times, covering news and languages of Southeastern Europe. It was available in a form of 22,000 instances per language, each no longer than 100 tokens. We have now published all available content from the SET Times website in the form of now 9,000 documents. The documents are separated into a train, development, and test set in 8:1:1 ratio. We made sure that given that the dataset consists of the same content in the three languages, there is no leakage of parallel data across these three subsets. Okay, the second is based on tweets. Harvest is with the TweetCat tool. This dataset was used as the out-of-domain testing data in the third iteration of the Verdile share task, but in significantly smaller volume than what we included in this benchmark. We shared tweets of 614 users, Serbian, Croatian, Bosnian, and Montenegrin. Okay. The benchmark allows for training on any of the two training datasets. Okay, experiments. I guess I'm less interested in the actual baselines. How good are they? Set times, test data, train data. And then the new approach. Feature extraction. And then the results. Impact of amount of training data, per category performance, and conclusion. Limitation. Given that we have used a significant amount of data for training the web model, we perform an additional analysis of the dependencies. Okay, that's not interesting. Per category performance. What's the biggest confusion? We conclude the results section with an analysis of the per category performance of both models. We present the performance by confusion matrices. We can observe a good performance of both models on Croatian and Serbian, with a decent performance on Bosnian, especially with the MD web. However, the performance on Montenegrin is very unsatisfactory in case of both models. While the SVM four out of 11 are only correctly classified. Well, I guess the models are trying to to tell you something. They can't distinguish between the languages. In this paper, we introduced the benchage. Okay. Montenegrin cannot be classified. Besides improving the identification of Montenegrin, there are many other directions. Monte and Negrin. There are many other directions we hope that the committee will investigate. One direction is exploiting linguistic features known to vary between the 4 languages. We have performed an initial experiment on the latter. Fine-tuning. We have performed an initial experiment on the latter, fine-tuning the Bertic model for one epoch on these documents. During this first epoch, we consistently obtained low results with no tendency of improvements. Limitations. The linguistically motivated methods might be also more reliable, as they would be based on rules and lexicons defined by linguists rather than training corpora with unknown biases. We are aware that the training the models with our method might introduce some bias to the results because it is based on identifying words that are specific. Consequently, some of the identified words might be more connected to topic differences. For instance, one of the words specific for Croatian is kuna, a former Croatian currency, which is more of a culture specific than a language specific word. Finally, using top-level domain information for assuming language labels is a weak supervision method and is less reliable than manual annotation. With this approach, we presume that the majority of texts published on the top-level web domain are written by native speakers of the language that is associated with the respective country and its top-level domain. However, we are aware that it is possible that some texts are mislabeled and actually written in another language. We cannot be sure that the authors of these texts are native speakers, live in their respective country related to the national web domain, or that the text is not a publication from another source in our language, as was shown to be the case for the British American English dataset in the discriminating between similar languages shared task in 2014. We presume that all text from a specific national top-level domain are written in the main official language of the country. However, we are aware that there are national minorities of each of the analyzed languages that live across the borders where the language is officially spoken, and that we can, for example, find a Serbian minority living in Bosnia and speaking Serbian on the Bosnian national web. By labeling all web text from the Bosnian domain as Bosnian language, the resulting model could discriminate towards the minorities, equating their language with the language of the majority, publishing on the national domain. We are aware that our weak supervision approach is a bit simplistic in regards to this issue, and while this is out of the scope, we plan to analyze this issue further in the future. Okay, fun. I guess I have one more question for Nicola. Did they, question for what is the source of supervision for parallel only the top level domain? Okay, and then we'll see here download, whoops, HBS M from macro. Okay. Okay. Looking good. Cool, guys. That's it. I'm gonna put this one in the description as well of this stream. And we are done. We are done for today. Let's continue tomorrow in the morning. We'll start downloading the data for Bosnian, Croatian, Serbian, Montenegrin, and then we can analyze the data, and then we can start some training until the end of the day. That's the plan for tomorrow. Okay, guys, have a good evening, have a good day, have a good morning, depending on where you are. And until tomorrow, cheers. I'm starting the stream tomorrow a bit earlier, likely around 9 a.m. already, because I have some meeting in the middle of the day. So that's the plan for tomorrow. Again, that's Central European time. And check out the Open NLLB channel where we are discussing all of this. So yeah, that's the what I'm trying to say, update for tomorrow. Cheers, see you tomorrow.